kind of didn't really make a big deal about the curly braces. And I said, like for the most part, as long as your curly braces are in the right position, even if they're improperly spaced, JavaScript is smart enough to kind of handle the spacing for you. It was just kind of a pain for humans to look at. But kind of wrapped in that statement is the fact that your curly braces do have to be in the right places, right? You could have 10 extra spaces after it, but your curly brace needs to be in the right place. And the reason why is because of something called scope. So there's a few different types of scopes, and then we'll kind of also talk about how they're used and what are some kind of, I guess, more like pitfalls associated with misuse of scopes. And we'll also talk about, I think someone yesterday asked about var versus let. We'll also talk about kind of why JavaScript has now migrated over to this use of let more so than var, and what the differences between the two are. Okay, scope. I like to think of scope as basically a sandbox. It's like, so everything, so a scope is created by a curly brace, and where the curly brace begins and where the curly brace ends, everything in between those open and closed curly braces is considered as scope. There are different types of scopes, and we see scopes in different areas, right? When we write a function, we start with a curly brace, we write our function of the body of our function, then we close it with a closed curly brace, right? When we do an if statement, we have an if conditional open curly brace, bunch of text or bunch of code, close curly brace, and that's the scope for that if statement. Um, Likewise, when we have a for loop or a while loop, we use curly braces in all of those cases. And for the purposes of this lecture, think of every time you see a curly brace as if we're creating a sandbox kind of just for that particular aspect of the code. So when we have a for loop and we have an open curly brace and a closed curly brace, it means we're creating a sandbox just for that for loop or while loop or if loop. And so why is it important that we define where scope is? It's because things we create speak or rather, it's because a scope kind of tells us what we have access to and what we don't. Um, and so if I look at this code here, right, like if I have a variable called wow, like we expect this to be able to work because like at line 5, it says, oh, okay, I'm looking for a variable wow. Where is it? Oh, okay, it's there being defined on line 4. And so what this means is that this wow variable is in the scope. In this case, you'll notice how there's no kind of open and closed curly braces, right? We start from our page and we just kind of start writing code. And that's because everything kind of has like a master parent scope, if you will, and it's called the global scope. And so by default, if you don't see any curly braces and you see it just kind of start typing, this means that all of this exists in something called the global scope. It's like the outermost scope. Like everything in the global scope is accessible to everything else, right? On the other hand, if I tried to or right, okay. So one thing about variables is variables like variables a variable scope is defined based on where it was created, not where it is used. Okay, and that's something that's you'll see as a pattern in a lot of different concepts too. Where we create something is kind of where the parameters of it are defined, right? So if I have a variable here called global on line 6 and I console log out on line 8, that works. If on line 10 I have a function, and inside this function I'm console logging out global, this also works. And so this is a very important nuance of scope, which is that if you think about kind of every single scope as its own little sandbox, the point of scope is that you can look in your sandbox for the variables that you want. You can also look in your quote unquote parents sandbox for the things that you want, right? As in whatever you're in, like whatever your scope has, that's fair game to you for you to be able to use. And also whatever your parent scope has, as in whatever other scope that you're also in, you also have access to those variables as well. And so if you put yourself in the position of line 10 here, inside this fun function, on line 11, we're trying to look for this variable called global. And the truth is between lines 10 through line 12, within this fun function scope, there is no variable called global, right? Like there's nothing called global in there. And so it says, okay, let me look at my own scope first, right? Let me look at my own curly braces defined between lines 10 and 12 and say, does this variable called global exist? And it doesn't. So then what it says is, hey, let me look in my parent scope, right? Let me look kind of outside one layer, if you will, to see if there's a variable called global. And in this case, there is a variable called global, and it's a string. So when we print out this global here, JavaScript's going to try to look inside this scope first. If it doesn't find it, it's going to look on the outer scope. And if it finds it in the outer scope, it will be able to use it. So scope is something that only works, I guess, unidirectionally, right? It can look in its scope, it can look in its parent scope, it can look in its parent scope, all the way up to the global scope. But it's unidirectional in the sense that you can look in your parent scope, but you can't look in your child scope. And so in the next example that we see here, okay. Oh, sorry, a bit of a detour here. This is basically saying that in a lot of cases, and we'll talk about kind of why this is in more detail. But for now, just kind of take it for granted that you really can't use a variable. Or rather, a variable is not going to have the value that you think it has if you define it after you use it. We'll talk about why this actually doesn't throw an error, and instead why it throws an undefined in a little bit. But yeah. Okay. So in this case, if we think about this function here, right? This function is going to create a variable called message, right? It's going to be a string, and we console log it out. And if we look at just happy function, we think, okay, well, this makes total sense, right? I create a variable and I use it right away. That makes sense. And when I execute happy function on line 10 there, that is going to print out I am so happy. However, on line 11, we're also trying to print out this variable called message. Okay, and so here's where the single directionness of scope matters, right? If I'm inside this happy function, I can go look in my scope. I can go look elsewhere on the global scope, if you will, so to speak, for this variable called message. If I'm here on line 11, where am I looking for that global? Where am I looking for the variable message? Or rather, if I'm on line 11, what scope do I have access to? Global. Right. You only have access to the global scope. And as far as the global scope is concerned, lines 6 through 7 doesn't really exist, right? Because you can only look in your scope. You can look in your parent scope. You can't look in your child scope, right? And in this case, this function, it's defining its scope within the global scope, right? So basically, for this console log on line 11 here, we can look anywhere on this page except between lines 5 through 8, because in lines 5 through 8, we're creating a new scope, and it's a child scope, right? It's like I suggest I give really bad analogies here, but it's like one way to think about it is you think about kind of like a bank account, right? Like if you're, let's say, living in New York and you're having trouble making rent or making payments, right? Like you have access to your money, right? And you may or may not have access to your parents' money. They may or may not be willing to help you or support you in some way, right? But if you have a kid, you can't take your kid's money, and you can't take your siblings' kind of money. I don't know, not the best analogy. But in this case, it's kind of like this concept. The analogy I'm trying to get at here is that like you have access to your scope, you have access to your parent scope, but you don't have access to kind of parallel or sibling scopes, and you don't have access to your children's scope, right? And so in this case, this happy function, this is a child scope, right? I have my global scope, and then within this global scope, I'm creating this brand new separate scope. But if I'm on the global scope, I know that there's another function there, but I can't look inside that scope, right? Like that is off limits to me. And so that's why on line 11, when we try to console log out message, we get a reference error. And you can't see the text in the red, it says reference error, message is not defined, right? Because as far as the global scope is concerned, the variable message doesn't exist. There's nothing on this global scope that says let message equal blank, right? There is in this kind of, in the child scope, but as far as line 11 is concerned, this is a black box. Everyone cool with that? Is everyone actually cool with that? Because if you get this, then the rest of this is going to be really easy. Right? This is like the fundamental part of scope. Okay. So the next question, or the next kind of thing to talk about is, Okay, what if a scope is or sorry, what if a variable is defined multiple times, right? In this case, uh, we have login message, right? And this login message, we create a variable called message on the global scope. We create another variable called message within this login message scope, and then we try to print out message within this function. Which one do you think shows? Which one do you think shows up? Well, actually, the answer is given to you. Okay, never mind. It's kind of a rhetorical question. Um, Anywho, so remember what I said yesterday about computers being really, really bad at ambiguity, and it still holds here. It still holds true here, right? Computers will look for things in a certain way, right? It will look within its own scope first, top down, or no, sorry, that's a bad way of saying it. It will look in its own scope first, and then it will look in its parent scope. And when it looks in any given scope, it will try to find the most recent value of that variable up to the point in which you're using it. Okay, so I'll talk about what that means like probably later on. But for now, at least, if I'm if I'm a computer and I'm executing this code here on line 9, when I console log out message, I look in my own scope first. If I don't find it in my own scope, then I'll go look at my parent scope, right? Back to the bank account analogy, like you should be kind of relying on your own resources first, and then if you need help, you look to other places for help, right? But your own scope is going to be the first place that you look at, right? And then if you're, and then if like let's say you don't have money, you look for your parents for help, and if your parents can't help you, maybe you look for your grandparents for help. Right? It's like there is a very clear sequential chain where you look more and more outwards, but by default, you always want to use things in your own scope, and then you want to use the next closest scope. So in this case, it's going to look for a message and say, do I have it in my own scope? Oh, I do. It's called act locally. Great. I'll put it out, right? It doesn't actually even look or care that there's another variable called message outside of it on a different scope, because guess what? Like this will never use it, right? It's like I got what I needed. I don't need another one, right? It's just kind of superfluous at that point. So when we talk about functions, functional scope, it's the idea that like in this case we have these curly braces and it's being set within the confines of a function.
David?
Yeah.
So when you work as an engineer, you shouldn't be concerned about using the same variables locally as some global. So if you name them the same, it won't be an issue, or you should try to avoid that.
Yes and no. Like so so one, you can see why using descriptive variable names kind of makes it a lot easier, because if everyone's using let x equals, like x goes crazy, right? And there's like a bunch of things and you don't really know what it is. One kind of best practice with regards to programming in general is you use functions to do one very simple, very specific thing, right? And so what you want to avoid is having a function that does like 20 different things in a sequential order, all in one function. Because each function should be doing one specific thing very clearly and very well, you also don't want a function to have anything more than it needs to do that one thing really well. So for example, if you have a function whose entire purpose, if you will, or rather last night when you wrote 0 dark 30, right? You have a function whose entire purpose is to take out all of the zeros from a string, right? That function only requires really one thing, right? And so you really should kind of keep in that paradigm of saying this is only going to have as many things as I need. So I'm not going to say like there's no instances in which you don't have to replace this, because there might be. So like using a local variable to overwrite kind of a parent one is definitely a common practice. It's also not the best one. Like it's not something you want to use kind of too much. Um, and a few reasons for that, right? One is because if you define this right here, we're kind of overriding the outer version message with act locally instead of think globally, right? If we have another function inside of here that actually want to use this outer one, well, then this would overwrite this, right? And so there's just like a lot of common things. Like there's not like a yes or no answer. It really depends on the situation. But in general, generally speaking, you want your code to be as clear as possible. And if you just have multiple things with the same name that represent different values, it's just less clear. So I would caution against it, but there is a very valid use case. And in fact, in next week, you'll work on a few problems in which you actually want to replace. Like there's a kind of a global default value, and then when you're in your functions, you want to replace it. So there is like definitely a use case for it, but I'm always on the mindset that like if I see message anywhere on this page, like it's just it'd be great if only one, right? If you need to create another message, like call it something else. Yeah, yeah. Okay. Is this a what if a variable is defined globally and locally? Oh, okay. Yeah, I mean this is just saying can't find it locally, gonna look for it globally. So a rehash of our first slide, if you will. Yeah. Okay, so here's something that I think folks sometimes also just kind of take for granted, but just so you kind of have it in the back of your mind here, parameters. Um, when I pass something into a function, right? Like here, I can pass in whatever I want. There's no restrictions, right? Here, whatever I pass in is going to be called message. We're going to be called this thing, and we call this a parameter. So whatever. So this is more a terminology thing. Whatever goes into it, we call an argument, and whatever we use within the confines of function, we call a parameter. So they're representing somewhat of the same thing, but just when we talk about it, like when I say argument versus parameter, I am talking about like the same kind of thing. But when I say argument, it usually means like whatever gets fed into the function. And then when I say parameter, it just means how we're using it or what we're using inside the function, right? So in this case, message is a parameter. And you might see this parameter called message, and we use it like we do any other variable, right? And that's because this is just like any other variable. What I kind of always try to think about here is if, for example, if I look at this code here like 0.30, right? I have a num. I'm trying to console.log out num. You can almost imagine there being like this imaginary line here that says let num equal whatever is being passed in, right? So the reason why I do this is to show you that num is one variable. Two, this num variable only exists within the confines of this function scope. And then this num variable also takes on the value of whatever is being passed in. So this is another way, so to speak, to create a variable without using let or var or const. But it's basically doing the same thing as using a let, a var, or a const. Any questions on this? Bam. So that's why when we come back to this, oh wait, wow, yeah. So that's why when I come back to this and we say parameters also locally scoped, it means if I have a function that has a parameter, this parameter is confined to the local scope of only the function. If I try to, well here, if I log out message on line 9 there, if I console log out message on line 10, for example here, it wouldn't look inside here, it will look inside here, right? One, because we can't look into other other kind of child scopes, but also, well, I guess that would be the main reason why. But it's also because message just doesn't exist, so to speak. Like if we call this like MSG, for example, inside here, we can't use it anywhere else outside of that function. So parameters are also confined to the function in which they are defined. And so one thing that you'll come across also is this idea of a nested function, right? We have a function, and within that function we have another function, right? And the reason why we use this is pretty simple actually. Sometimes we have a function that might say, hey, can you do these 5 things? And that function will say, well, I can't do all 5 of them, but I'll create a function for each one, and I'll just call them in order. And it's kind of a better modular approach to writing code, right? Where we still have kind of one function, or each function being responsible for a very single specific task. Anywho, so in this case, we have an outer function called outer, and we have an inner function called inner, right? In this case, if we think about this line 9 here, right, this kind of so the way to read this code, right, is we go through line 2, right, we define its global var. Then lines 4 through 12 are creating a variable for us, or creating a function for us. But right now, I actually don't care about it because on the first pass through, I don't even know if this outer function will ever be used, right? So I can just kind of like glance over it. Like no code is actually being executed here. Nothing's being invoked. But when I get to line 14, I'm actually invoking the outer function. So I go from line 2 to line 14, then I go back to line 4 and try to walk through what's happening here, right? So on line 5, we create an outer var variable. Line 7 through 10 doesn't matter yet just yet because we're creating a function that I may or may not never use. Once again, nothing's being invoked. On line 11, we actually are invoking it. So after I go from line 2 to line 14 to line 5 to line 11, and now I'm going back to line 7, 8, and 9. Okay, so that's kind of how you should be thinking about reading this code.
So can you just repeat that, please?
Yeah, sure. So if I'm a computer and I try to execute this page of code, right, the first line I run is line 2, right, because there's an operation here. I'm assigning a value to a variable. Okay, I didn't skip over lines 4 through 12, like functionally, because there's no code being executed, right? I'm creating a function, but I don't know if I'll ever use that function, right? And if I don't use that function, like when I look at it, like I don't actually need to like worry about it just yet, right? I just need to know that it exists, but I don't need to worry about it just yet. So that's what I'm saying. Like for us, when we read this code, like the way I kind of read this is like, okay, on line 2, I need to read it because we're doing something very clear, right? Lines 4 through 12, we're doing something, but it's not clear if it will be used down the road, right? Line 14, oh, okay, I have to read that one because we're actually doing something now, right? So that's how I jump from line 2 to line 14. Line 14 says I'm invoking this outer function. Okay, so let's find where the outer function is. The outer function starts on line 4. Okay, now I have to read everything inside this outer function, right? And so the first thing is line 5. I create a variable. Yep, got to read that. Line 7 through 9. Once again, I'm creating a variable that I'm not sure if it'll ever be used. So for now, we don't have to kind of go into it just yet. But on line 11, we actually use the inner variable. And so for me to be able to properly invoke it, I now need to kind of understand what's inside the inner variable. What I'm trying to caution people away from is just like, oh, like let's read code from top down, and so we define global variable, then we create outer var, then we run this, and we do this. But like no, like computers run on a very clear like this asks me to do this, and then this asks me to do this, right? It's not a straight like top down. Like if line 14 wasn't on this page, then nothing between 4's line through 12 really matter. That's kind of like the gist of it. But the important thing here is when we look at line 9, right? That's kind of the thing that's being kind of really printing something out to us. And by the way, if you're not comfortable with returns, like do some digging and like think about how to use returns. Okay, console logs, and returns are very very different. In the sense, especially in the sense that console logs, the way I think of console logs for the most part is they're there to help humans read and understand code. To a computer, they mean nothing and they don't do anything, right? It's purely there kind of for our benefit. And so if you're console logging out something, it doesn't mean like to a computer, it's almost like that code doesn't really exist, right? So don't think a console log is going to replace a return statement because it doesn't. The return statement does a few things in particular. One of which is that it will give back a function, and the second one is that it will end a function at that point, right? And so I know a few groups yesterday had return statements kind of all over their function, right? And they had it within their for loop. And one of the things I think you'll quickly realize is like if I have a for loop and I have a return statement, as soon as that return statement hits, I'm not only done with that for loop, I'm also done with the function that the for loop was in, right? So returns in general should be the very last thing that you do in a given function. You should like once I see a return, it should mean this function should be over by now because nothing after is going to run. So I just want to caution folks here, like when we do these examples, we use console logs because they're a little bit easier. We can print things sequentially. It's hopefully a little bit more clear. But don't think console logs are a substitute for returns because they're not. Okay, anyway, line 9. We're console logging, so we're just printing out these three variables, global var, outer var, and inner var, right? And yeah, so if we go from left to right, let's take a look at global var first. Where's global var? Is there a global var inside this inner function scope? The answer is no. Okay, is there a global var in our parent scope, in this outer function scope? And the answer is nope. Okay, let's go out one further. Oh, okay, look, it looks like we're at the max outermost scope now, the global scope. Is there a variable called global var? There is. Okay, let's use that. Okay, same for outer var. We don't have it in our scope, but our parents have that variable in their scope on line 5, so let's use that. In the inner var, we have ourselves, so there's no point looking further out. Let's just use the one that we have in our own local scope. And so when we do this, you can see us being able to kind of access, different variables from different scopes. But really, at this point, all we're really doing is accessing the closest variable available to us still. Cool? Good? Yeah? All right. So this is just a few more examples of probably a very similar concept here. So in this case, we have something called collision, which we call a global scope. Then on line 4, we have our own variable called collision, but this time collision is a parameter, right? It's a parameter, so therefore, in this outer function, we have our own version of collision. And in this inner function, we have our own version of collision, right? So now we have an instance in which the variable collision is being defined 3 times. Once on line 2, once on line 4, and then once on line 7. And so if we're console logging out from this inner function, we're going to say, great, do I have a collision in my own inner scope? I do. It's called inner. Done. That's it. We don't need to look anywhere else. If line 7 didn't exist and we try to console log a collision, we would look for it in our parent scope. And our parent scope does have it in the outer function, so we'll use outer. And then if our parents didn't have it, then we'd go out to the global scope. And so this is I should kind of decide first. Yeah, so then this is like the idea of where like if our inner function didn't have a collision variable, then we would look to see if our parents had it. Our parents do, it's a parameter. So then we print out the outer, or rather the collision variable in the outer function scope. And then lastly is if the inner doesn't have it, the outer doesn't have it, but the global does, we'll use global. And then this is just a repeat of this idea that, like, remember, we can look in our scope, we can look in our parent scope, we can look in any child scopes, right? So on line 11 here, we try to console log out inner var. You'll notice inner var is defined only within this inner function, right? And by the way, notice how the indentation kind of tells me, it gives me a quick sense of kind of where the scope is, right? This function and this console log are on the same indent level, which means they're not parent-child, they're what? They're siblings, right? So this function and this console log are on the same indentation. They're siblings, which means which means that line 11 can't look in the scope of line 11 or of line 6 of the function of line 6 because they're siblings, and we can't look in sibling scopes. So in this case, when I try to console log out inner var, I'm going to get an error saying, as far as line 11 is concerned, inner var doesn't exist because it can't look inside line 7 and 8. Yeah.
Sorry for that. How would you read it? So you would go for line 14 and then you would go into the function, and then line 10 you would go into line 6.
Yeah. So the first thing I read is line 14, right? And then I would execute line 4. I would execute line 10.
Yeah.
Line 7, line 8.
And then line 11.
And then line 11.
Right.
Yep. Here's where the slide probably just gets like, a little bit repetitive now, so I apologize, and I'll try to go through it fairly quickly. Once again, when we look for outer var, is there an outer var in our inner function scope? Yeah, there is. That's a parameter. So we're going to use that. And then inner var obviously also comes from ourselves. So it's just to like kind of just show you that, look, like when you look for a variable, just be. And this is also why it's a bit dangerous to use the same variable name over and over and over again, because it's kind of like it can be hidden in different places and then it's not quite clear. That's why in most code, you always see folks define the variables at the top of the function or the page. And it's just because it just it gives the reader a comfortable sense of, okay, these are the variables I'll be using throughout this function. A lot of times you'll see people define a variable and not even assign a value. It's just to let the reader know, yeah, I'm going to be using this. Not sure where it's going to be yet, but I'll be using this later on. Okay. All right. Actually, why did this say undefined? Oh, it's undefined. Sorry, so this is a reference error, and this is undefined because this is undefined because we're printing out outer var, which is a parameter. But if you notice on line 11, when we call enter, we don't pass anything in. and so therefore this outer bar is actually undefined. It's not a reference error, right? Because outer bar does exist. We have a let outer bar, but what are we setting it equal to? We're setting it equal to line nothing, right? Whatever is being passed into line 11 is nothing, so therefore it's undefined by default in JavaScript. Okay, so if that makes sense to you, then no, not that fast. If that makes sense to you, then the rest of this should make sense too, right? Which is just to tell you that everywhere, like the way that we see a curly brace for functions, that also applies to block scopes, and blocks are just basically scopes, but for like the if loops, the while loops, the for loops, etc. Anywhere else that you see a curly brace, that's not a function, right? So in this if statement, if you will, on line 4 through line 7, we see the open and close curly braces, and we have access to that block variable because we're in the block scope for the if statement or if block. Okay. Okay. So jumping back to yesterday when someone asked like why we use let instead of var. So the idea of block scope, so the idea of function scope has always been around JavaScript. Like that's been pretty consistent. The idea of block scope didn't really exist in ES5, and what we mean by that is if you use something like var block, it not only creates it when it's inside the curly braces for the if or for or while loop, it also added it to the function that it was in as well, right? And so in this case, so if I look in the previous, or the previous I do it, right? So here, if you notice, we have a variable called block, right? On line 5, we say Jenny from the, and on line 6, we say Jenny from the block. That makes sense. On line 9, when we try to console log out block, we're going to get a reference error, right? Because block only exists, this variable block only exists within these curly braces because we use let. On the other hand, if we use var instead, what var does is var kind of ignores the block. Like var will add it to the block, but it will also add it to the function too. And so if I use var, then when I print out this Jenny from the string is available both in the if statement, in the if block, and also in whatever scope this if statement itself was in, right? So var kind of made it more, it made the variable more accessible, but it was also less precise. And in computers, like I said earlier, how like with every single function, you kind of want to give it just what it needs to do the job at hand and nothing more than that. Var was kind of heavy-handed in the sense that like it just created a variable and it created it everywhere, or added it to the function scope, and there was no way to create a variable that was kind of only confined to the local block scope if we wanted to. And so the reason why folks are using let now a lot more than vars for this reason is because if I use let, I can be very, very clear about where I want this code to be used or who has access to it. If I use var, I kind of lose a little bit of that security, if you will. It also makes it more dangerous to overwrite other variables if you use var, right? Like within an if statement, it's very unlikely you'll have the need to redefine a variable more than once. But in a function, conceivably, there could be more use cases for it. Or there could be more scenarios which you want to redefine a function or redefine a variable over and over again. So that's why we use let now more, is because let takes into account not just the function block or the function, sorry, not let takes into account not just the function scope or the curly braces around the functions. It also takes into account the curly braces around blocks. So on and if loops, while loops, for loops, etc. Let is just a little bit more precise. And then best practices. Yeah. So typically speaking, you don't want to change global scopes. And the reason, or sorry, you don't want to change the value of variables on the global scope. You are able to, but the reason why you don't really want to is because things on the global scopes are accessible to everyone, metaphorically speaking, and so everyone uses it. And if you're changing it, then it means it changes for everyone else too. So if that's your intention, then by all means do it. But in general, you really shouldn't be changing things on the global scope, or you really shouldn't be changing variables on global scope unless you're sure no one else is using it. But one way to kind of get around that is you can always redefine your own version of the global variable, right? And just use that instead. The other, okay. The other thing about the other kind of corollary to that is there's very few instances in which you would actually need to use global variables for the most part. And so usually speaking, if you create a global variable, it speaks to a certain level of bad code hygiene, I guess. There's very few things that every single thing on the page should need access to. Like if you're building a web page, like maybe the security credentials could be something like global variable, but it's like that's something you probably don't want to show. You probably want to hide more so than just make public anyway. And so we're not going to say like never create a global variable, but within this class and then with most kind of normal engineering functions, you don't really want global variables. And the way to create a global variable, or a short way to do it, is if I do something like x equals 6 and I console.log out x, it works, right? Notice how here on line 1, I didn't put a var, I didn't put a let, I didn't put a const or anything there, right? If I just pull a variable out of thin air and I set it equal to a number, this is by default creating a global variable. So it's doable. It's just for this class, it's definitely bad practice. In the real world, it's very, 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 most usually bad practice. So just avoid using global scopes whenever you can, because generally speaking, there's very few instances in which you want to have a global scope, right? Anyone can read it, so it's not safe. Anyone can change it, so it's not really even safe for anyone using it. There's a lot of like really just potentially bad things with global variables. Yeah.
But you can also create it with let. It will also be global, right?
Yeah. You can create it with let, and it will be global. Yes. Yeah.
And if you create it without let, but inside of the function, is it going to be global?
So if you so no matter where you create a variable, if you don't use a let or a var or a const, it will automatically be made into a global variable. So you know it doesn't matter where you create it. The second thing, kind of to your point, is like if you use let, you're not really creating a global variable. And so for the examples that we've done in which our code is very simple and it's just like like a simple block of code, like the global is kind of like by default everything's on the global scope, right? In like when you work on an application, for example, if I work in Chrome, right, the global like what's a global variable or what's the global scope here, and if I do something like well, actually I don't even so the global scope is something called window here, and like so if I do window dot David equals true, like the idea is no matter where I am on this page, I have access to this global scope called window, right? And so like the short of it is like for our like demo purposes, the global scope is kind of like this like the top of the page, and it's very clear. In the real world, like when we build out applications, the global scope is something that's like a lot more like clearly defined, and you want to avoid using that. So like in the context of, let's say, if I want to build a web app, I want to minimize the amount of things that go on window, because anything else on this page can access that window variable. And in fact, if we look at what window is for the site, like it tends to typically be like things that almost have to do with kind of how the website's running, and less like, oh yeah, this function needs this variable storage. Like let's just put on the window. It's just like, yeah. I mean, not to belabor the point, but just try to minimize use of window scopes if possible. All right, I think I deleted the slide or something. Whoops. But that was it anyway. So any questions? that was the last slide. Just like try to minimize use of global variables whenever possible. Any questions? Yeah, Sophie?
Just to clarify, so if there are two, like if there is a function with a nested function,
Mhm.
the nested one can access variables of the one that contains it, but
Yep.
not vice versa, right?
Yep.
And if there is like another nested function in a like a third one, it can access both two functions, right?
Okay, so let's just write this out. So where do you want the third function to be now?
In a Sophie function.
Okay. 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 So what's the question?
So David cannot access any variables inside Sophie or Emily function.
Yep.
And Emily, it can definitely access Sophie variables, and it also can access David variables, right?
Yep.
Okay, got it.
Actually, what I'll do is I'll just do it this way. So this is.
And Sophie accordingly can access David and global, but not Emily.
Yep. Oh shoot. This might error out though. It's a bad part of this. Haha, I did that thing where I wrote a function, never ran it. Dang. Okay. I'll put this on the bottom of the page. Oh no, but it will still error out. Yeah, I mean, the short of it is yes. Like if I tried in this case, if I'm in the David function, only temp is accessible. These two, new temp and new temp, are gonna throw errors out. If I'm in Sophie, temp is available and new temp is available. New temp is not available. And if I'm in the innermost function, everything's available. Yeah. All right. Any other questions?